So if you're building a smart factory, the number one goal is getting all your machines to talk. I mean, how else do you listen to the heartbeat of your production line? Well, it really all comes down to two, let's call them fundamental languages. Today we're going to explore how machines communicate and why picking the right language is absolutely the key to building a system that's truly intelligent. Okay, so here's the game plan. We're going to start with the data itself. What are we even talking about? Then we'll check out two totally different ways to communicate. Path one is like a smart, efficient conversation. Path two, well, it's more like a constant checkup. Then we'll put them head to head and figure out how you choose the right strategy for your own factory.
All right, first things first. Before we can get into how machines talk, we have to understand what they're actually talking about. Because, not all data that comes off the factory floor is created equal, not by a long shot. We can basically split all this information into two main buckets. Over on the left, you've got production data. This is stuff like temperature and pressure that's collected only when a machine is actively building a product. It's directly tied to the quality, so it's super important. Then, on the right, you've got non-production data. You can think of this more like a routine health check for the machine itself. We're grabbing this info at regular intervals just to make sure the machine is happy and healthy no matter what it's making.
Okay, let's dive into our first communication path. I want you to think of this one as a really smart, really efficient conversation, one where the machine knows exactly when it needs to speak up.
So, this is called event-driven communication. In this setup, the central system doesn't have to constantly bother the machine for updates. Nope. Instead, the machine is smart. It proactively sends out a signal, we call it an event, but only when something important happens. The main system is just listening. It never has to ask a single question.
And just look at how clean this whole process is. A product comes in, the machine just says, hey, process start. It does its job, and when it's done, it sends out one single process end message, with all the important production data neatly bundled up with it. The system gets it, says, okay, track out, and the product moves on. It's just so efficient and incredibly precise. All right, let's switch gears and look at our second path. This one creates a totally different vibe. It's less of a polite conversation and a lot more like an interrogation. Yup, this is the polling method. Here, the machine is totally passive. It says nothing unless it's asked. So the central system has to constantly poke it with questions over and over and over again. It's like a kid in the back of a car. What are you doing now? What's the temperature? How about now? Are you done yet? Are you done yet? And you can see how this works right here. It all starts when a human operator scans a product ID into what's called the Manufacturing Execution System, or MES. From that second on, the system is locked in this relentless loop, just asking the machine for data every few seconds, and this just keeps going until the operator physically tells it the job is done. I mean, it works, but man, it creates a ton of conversational noise. Okay, so now we've met our two methods, the smart conversation and the constant checkup. So let's put them side by side, a proper showdown, and see what the real practical differences are. This table just lays it all out, crystal clear. With event-driven, the machine reports in. That means the network load is super low, the data timing is precise, and it's highly scalable. But with polling, the system is always asking. This creates a really high network load, you can get data delays, and here's the big one. It really struggles to scale once you start adding more and more machines. And just to put a picture to that, look at this difference in network traffic. It's staggering. Polling creates this constant flood of questions and answers that just clogs up your whole network. The event-driven method, it's just a tiny trickle in comparison. It's sending only what's essential exactly when it's needed. And here is the absolute bottom line. This is not just some small technical detail. Imagine a big factory, hundreds of machines all getting polled every couple of seconds. As you see here, that massive, overwhelming volume of data can literally crash your main control server. And that means system-wide slowdowns and, even worse, potentially losing your precious production data. That is a massive problem. So the smart way to handle this is to split the load. You let your main MES server handle the really critical stuff, the start and stop commands. But you take that fire hose of detailed trace data, I'm talking sensor readings every single second, and you offload it to a separate, dedicated server. We often call this an engineering data collection, or EGC server. This keeps your main control system from getting totally bogged down, which means it stays fast and stable. So after all that, you might be thinking, okay, so event-driven is always the winner, right? Well, the best answer isn't really about the technology. It's actually about strategy. And believe it or not, the ancient strategist Sun Tzu gives us the perfect way to think about this. He wrote that just like water changes its shape to fit the ground, a winning strategy has to adapt to the situation. There's just no single best way that works for everything all the time.
And that is exactly what's going on here. Look, polling can be a totally fine, low-cost solution if you only have a few machines and your data needs are pretty simple. But if you're building for scale, if you've got dozens or hundreds of machines, and you need top performance and stability, then an event-driven system is by far the superior strategic choice for the future.
So that really leaves us with one final question for you to think about. Is your factory system built for a quiet, intelligent conversation? Or is it constantly just shouting to be heard? Because that first step towards a truly smart factory isn't just about collecting data. It's about learning how to truly listen. Thanks for checking out this explainer.